These are the 5.0 notes for Algebra 2. So this is like before Chapter 5 begins, we're going to review some properties of exponents. We covered these properties of exponents in Algebra 1, so this is a refresh. Okay, so the first property that we're going to review is the product of powers. Now, I don't think it's specifically important that you know all the names, more that you know what to do when you see a problem like this. So product of powers. What it says is that you have something multiplying times another term and they have the same base. Do you see they're both a base of x? Then what you do is you add the exponents. So for example, if you have x cubed times x to the 8th, you add the exponents. They're both a base of x, so you can add the exponents and get x to the 11th. All right, now we also have a power of a power. And that is if you have something raised to a power being raised to another power. So x to the power of n being raised to the power of n. You multiply the powers. So like if you have x cubed and that is being squared, you take the 3 times the 2 and you get x to the 6th. Let's look at why both of these work. So the reason this works, the first one, the product of powers, just for example, if you have x squared times x cubed, x squared is like x times x cubed is like x times x times x. And all together, if you see that, there are 5 x's multiplying, and that's why you get x to the 5th. You add them. In reverse, if you have x cubed and you're squaring it, that means you're taking x cubed times itself. So you have x times x times x times itself, x times x times x. So all together, you have x multiplying by itself 6 times. That's why that works. Okay, let's do the power of a product. So if you have 2 things or more that are multiplying, so like x times y are multiplying, and they're being taken to a power of m, that power of m goes to everything in the parentheses. You can kind of think of it like distributing in a way. So for example, if you have 5xy and it is being squared, that squared needs to go to the 5, to the x, and to the y. And it ends up being 25x squared, y squared. All right, quotient of powers. Okay, so if you have something that is the same base and it is in a fraction, so x to the m over x to the n, you can subtract them. You do m minus n. So for example, if you have x to the 7th over x squared, you subtract the powers and you're left with x to the 5th. The reason why this works, take that as an example. If you had x to the 7th, that'd be like multiplying x times itself 7 times over x squared. You could cancel out 2 x's off of the top and the bottom, and you're left with x times itself 5 times, which is x to the 5th. Now, this also works if you have the larger power on bottom. So if you have like x to the 3rd over x to the 7th, that's like x to the 3rd as x times itself 3 times. X to the 7th is x times itself 7 times. So if you cancel out 3, you're left with 4 of them, but look where the leftovers are. They're on the bottom of the fraction. And so it becomes, instead of x to the 4th, it's 1 over x to the 4th. Because if the bigger power was on the bottom, then the ones that remain after you cancel are still going to be on the bottom. All right, power of a quotient is very much like power of a product. And so if you have like a x over y or something in a fraction with a power outside, that power gets distributed to everything inside, so it goes to everything on both the top and the bottom of the fraction. Okay, so for example, if you have like x over y and it's squared, then the x is squared over the y is squared. That squared power goes to everything inside the parentheses. All right, a negative exponent creates a reciprocal. So for example, if you have x to the negative n, you move it to the bottom of a fraction, and it becomes 1 over x to the m. So if you have x to the negative 2, it becomes 1 over x squared. So the negative up here in the exponent moves it down to the bottom, and once it moves down, now it's a positive exponent. This can also work if we have y to the negative 3rd power over x to the negative 2 power. The y to the negative 3rd, the negative 3 power moves it down to the bottom. Notice how now it's positive. And then on the bottom you had x to the negative 2. It moves it up to the top, and so x squared will join the numerator on top, and it is now positive. Once you move it, it's positive. And then last but not least, we have our 0 exponent. And so anything to the 0 power is 1. If it's in parentheses and it's all to the 0 power, then everything in that parentheses turns into 1. If you have something like this, x to the 0, y squared, z, only the x is to the 0 power, so only the x turns to 1, and you're just left with y squared times z. All right, let's use these powers on these examples. So this says 6.7 to the 0 power. Anything to the 0 power is 1 due to the 0 exponent property. All right, this negative 2 to the negative 4, I find it easier with variables. It's kind of tricky when they're just numbers. So the negative 4 exponent, the negative exponent moves it to the bottom. It's like the reciprocal. And so once I have moved it to the bottom, the exponent is now positive 4. The negative moves it down. Now it's moving this entire negative 2. So if you have negative 2 to an even power, that's going to become positive, because if you picture multiplying negative 2 an even number of times, these make positive 4, these make positive 4, and 4 times 4 is 16. And we're going to try to do this without a calculator because we're trying to get the property of the exponents. Is like the important part. Okay, this expression, 4x to the 0 over y to the negative 3. The x to the 0 becomes 1 because anything to the 0 power is 1. Now, only the x is raised to the 0, so the 4 is still there. So right now we have 4 over y to the negative 3. Now, this negative exponent is going to move the y up, and it becomes 4y to the 3rd. And there's nothing on the denominator, so this is just my answer. All right, look at example 3. These are both a base of 3. The base is the same. So if they're multiplying and they're the same base, you can add the exponents. So we get 3 to the 8th. And it said write your answer using positive exponents. So I'd say it's fine just to leave it with an exponent. All right, right here, these are both the same base. They're both a base of negative 4. So that means I can subtract them because they're in a fraction. So I can do 2 minus 7. And so I'm getting to the negative 5th power. And then a negative exponent, remember, creates a reciprocal. So if it's on top, it brings it down to the bottom. And now it's a positive 5th power. So that's because once this negative right here moved it down, now it's positive. I feel like we could leave it like that. If we wanted to know what it was, then it is 1 over negative 1024. But I feel like this answer is fine because it did say write your answer using positive exponents. So I think it's fine to leave it in the exponent form. All right, this one right here is a power of a power. So z to the 4th is being taken to the negative 3rd power. When it's a power to a power, you multiply them. So you get z to the negative 12th. And then a negative exponent moves, it's a reciprocal, so the z to the 12th moves down to the denominator. So it's 1 over z to the 12th. And then on example 4, here we have negative 1.5y being taken to the squared power. This is the power of a product. You take that squared to everything in here. So you do negative 1.5 squared and y squared. Now, when you do negative 1.5 squared, you're taking negative 1.5 times itself. So that should end up positive. So it's 2.25 y squared. All right, this one right here on B is the power of a quotient. So this cube goes to everything. So you're going to have a cubed, and you have negative 10 cubed. Notice how I put the negative 10 in the parentheses. The cubed is applied to all of it, not just the 10, but a negative 10. So the negative 10 cubed, we could leave it there, but since it's kind of a small number, I feel like it's fine to go ahead and figure out. Negative 10 times negative 10 makes 100, and 100 times negative 10 makes negative 1,000. All right, trying our best to do these without a calculator. All right, on this one, this is once again, we have kind of a combination of a power of a quotient and a power of a product. This fourth power goes to everything, including the 3. So 3 to the 4th, d to the 4th, 2 to the 4th. And if we know what those are, 3 to the 4th is 3 times 3 times 3 times 3. That's 81. D to the 4th. And 2 to the 4th is 2 times 2 times 2 times 2, which is 16. So 81 d to the 4th over 16. All right, this one is the same thing. We've got a kind of a power of a product and a power of a quotient where we're distributing. And then we also have a negative exponent. So we have 2 to the negative 5th, x to the negative 5th over 3 to the negative 5th. Now, the 2 to the negative 5th moves to the bottom and becomes 2 to the 5th. The x to the negative 5th moves to the bottom and becomes x to the 5th. And the 3 to the negative 5th that was down here on the denominator moves up here and becomes 3 to the 5th. Once you move them, notice I made them positive. So we can leave them like that. We can't combine this 3 to the 5th and 2 to the 5th because they're different bases. If we did know what 3 to the 5th was, we could go ahead and change it. It is 243, and 2 to the 5th is 32. So I would feel comfortable, though, also leaving it like in this format, just because they said just write it as positive exponents.